Okay, so here we have question number 3. We have some oil that is in a liquid state, but then it's cooling down in a freezer, and then it starts to freeze. You can see after 30 minutes there. So yeah, energy is being removed from the sample. We have the mass of the sample, and we have other pieces of information. So yeah, first question is to calculate the thermal energy transferred from the sample during the first 30 minutes. Pretty straightforward. We know that the power rating is 15 watts. That's the rate at which energy is being removed. So we just need to multiply by 30 minutes, which is 30 times 60 seconds, and we get 27,000 joules. Then we have to estimate the specific heat capacity. Okay, so we know that per definition is energy over mass over temperature change, and we can see that in 30 minutes the temperature changes by 40 Kelvin. So 27 kilojoules is removed, the mass is 0.32 kilograms, and the temperature difference, yeah, is 40 kelvins. 40 Kelvin. And then we can work that out, and we get roughly 2,100. And then it says, state an appropriate unit, so you have to really add the unit to this question, and it comes out as joules per kilogram per Kelvin. So yeah, very important. Okay, so here we have to explain in terms of the molecular model of matter why the temperature remains constant during the freezing. Okay, well, we have to know that when a substance undergoes a phase change, then the intermolecular potential energy changes, but the average kinetic energy of the particles doesn't change. So as a substance freezes, the intermolecular potential energy decreases, removing potential energy, but the average kinetic energy per particle remains the same, remains constant. But then we know, of course, that the average kinetic energy per particle is proportional to temperature, or temperature is proportional to this average kinetic energy per particle. Remember this formula, 3/2 Boltzmann's constant times temperature equals to the average kinetic energy per particle. So therefore the temperature also remains constant. Okay, so it's intermolecular, PE decreasing, but average kinetic energy per particle remains constant. Therefore the temperature also remains constant. Okay, so now we're calculating how much mass actually freezes. So it starts freezing at this point after 30 minutes. So after 60 minutes, how much is still unfrozen? Well, we can calculate how much energy has been removed during the freezing process. It's been freezing for 30 minutes. So that's again 27,000 joules that's been taken out of it. And if that much energy has been taken out of the system, then we can calculate how much of the mass has frozen. So we just use the latent heat there. Remember, the latent heat is Q over M, so M is Q over L, and we can look up the latent heat in the problem, and then we get around 0.21 kilogram. And then we can calculate the unfrozen mass. That's of course the total mass we had to begin with, 0.32 minus the 0.21, and then we end up with 0.11 kilogram.